Hello dear students, this is Miss Enass and I am here today to introduce a lesson about momentum. After this lesson, you are supposed to be able to know what is momentum, like defining momentum. 2, you have to be able to understand the law of conservation of momentum. And finally, calculate momentum changes taking place at events or collisions. So let's begin with objective number 1, defining momentum. What is momentum? To understand the concept of momentum, I want you to imagine yourself standing up in a race track and 2 runners are running toward you with the same velocity. Both of them are running toward you with 65 meters per second. Now, how unpleasant would it be to be hit by one of these runners? I want you to conclude or imagine which one of these runners will hit you more severe. The one with 40 kilograms mass or the other one with 60 kilograms mass. Now, I believe now you will conclude that the 2 variables that the strength of the head depends on are the mass and the velocity of the runners. So momentum, as a physical quantity, it depends on mass and velocity. To simplify this, momentum would be represented as P, mass as m, and velocity as v. And because velocity is a vector value, so momentum has to be a vector value too. A vector value, to remind you, is a value that depends on both magnitude and the direction of the object. So momentum is dependent on direction as velocity. So it's a vector value. It has a magnitude and it has also a direction. The unit of momentum now depends on the unit of mass and velocity too. So momentum, mass kilograms, velocity meters per second. So the unit of momentum P will be kilogram from the mass dot meters per second from velocity. So now let's take a simple example about how to calculate momentum. Let's take the racer's example. For the first racer, we will calculate the momentum of his as his mass, 40, times his velocity, 65. So using a very simple calculation, I would find out that it is 2,600 and the unit is kilogram meters per second toward, and I have to mention the direction, toward my left hand. So to the left. To calculate the momentum of the second racer, momentum P is the mass of the second racer is 60 times the velocity of his is also 65. The value would be 3,900 kilogram dot meters per second, also toward my left hand, so to the left. And here's the thing, 2 notes. I have to mention the direction because momentum is a vector value. Now, a question for you students, which one has a greater momentum, greater impact when collision? Now, the common sense says the racer 2 because the value is greater. So if you have been hit by the second racer, the impact is going to be more severe than the first racer, which means when the mass increases, the momentum increases. The impact of collision is going to be greater. And also, when the velocity increases, the impact is going to be greater too. Very essential piece of information you have to know, student, is regardless the mass of any object, if its velocity is 0, the momentum has no value. It's going to be 0. So momentum has to have a moving object, number 1. Now, we will talk about the law of conservation of momentum. Because we're done now with the step of defining momentum, we understood the variables that momentum depends on. So you might ask me, what is the law of conservation of momentum? I will tell you it is the total momentum before a collision or an event equals the total momentum after a collision or an event. And you would ask me, teacher, what does that mean? Well, to understand this, I want you to take a look into this example. If I have a gun and I have a bullet inside the gun, before shooting, which is the collision or event, I'm talking about the event, and the event in this case is the shooting. Now, before shooting, what is the momentum of the gun and the bullet? Because I'm talking about total. So when talking about total, I'm talking about the two objects here, the bullet and the gun. For both of the bullet and the gun, the momentum is 0. Because as we said earlier, something essential to remember, that if the velocity is 0, the momentum is 0. Because the gun has a mass, but it has no velocity. And the bullet has a mass, but it has no velocity. So before shooting, which is the event I'm talking about, the total momentum of the gun and the bullet equals 0. So now let's take a look into after the event, which is the shooting case. After shooting, I have a forward momentum because I have a mass and velocity to the right. I have a forward momentum of the bullet, and I have a backward momentum because I have a backward velocity for the gun. I have a backward momentum. And according to Newton's third law, the momentum forward has to be equal to the momentum backwards. And because momentum is a vector value, it depends on the direction. And when I have two similar magnitudes in opposite directions, the total momentum of both objects after the event, which is shooting in this case, equals 0. So the total momentum before an event is 0, and the total momentum after the event is also 0, which is the law of conservation of momentum. Now, dear students, let's solve questions together in order to cover the last objective of calculating momentum changes taking place within collisions or events. So let's take this example. A gun has a mass of 2 kilograms and it moves backward with a velocity of 5 meters per second, and the bullet will move forward with unknown speed and its mass is 42 grams. Now, what the question wants me to find out is to calculate the velocity of the bullet, then its momentum. Now, I'm talking about a case of after the event, which is after shooting. So, going to the concept of the law of conservation of momentum, the momentum before collision equals 0 and the momentum after the collision, I'm talking about the total momentum, before collision is 0 and the total momentum of the bullet and the gun after collision equals 0 too. So, the momentum of the bullet has to be equal to the momentum of the gun after the event, but in opposite directions, as we said earlier. So, we will calculate now the momentum of the gun, which is the mass of the gun is 2 kilograms times the velocity of the gun, which is 5, which is, now the answer is 10 kilogram meters per second. Now I'm talking about backwards. This is the momentum of the gun. Now the momentum of the bullet, P of the bullet, is the mass of the bullet times the velocity of the bullet, which is, now the mass of the bullet is 42 grams. And here is a very important tip for you. You have to use kilograms, not grams. So I have to represent grams as kilograms by using scientific notation 10 to the power minus 3. So this is now the kilograms representation of the mass times the unknown value of velocity that I want to find out. So now let's proceed the calculation here in order to find out the value of V. So 10, 2 times 5, the momentum of the gun equals 42 times 10 to the power minus 3 times v, the value of the velocity of the bullet I want to find out. Now, I will divide by 42 times 10 to the power minus 3 both sides. 42 times 10 to the power minus 3. Finding out that velocity equals 0.23809 times 10 to the power 3. And here's the thing, you have to use the scientific notation when you want to write the numbers or the values. So I prefer that you represent the number as 2.38. You may round it to 81, or you may keep it as 09, or you may just erase it, and I will erase it. I hope it's clear. Times 10 to the power 2, because I moved the decimal point 1. Now, step 2, the question, I want to find out the momentum of the bullet now. I found out the velocity. I want to find out the momentum. And the rule of the momentum of the bullet is its mass times its velocity. Now, the mass is none from the question. 42 grams in kilograms is this. 42 times 10 to the power minus 3 times the velocity that I just found on this part of the question. Here we go. We will put the number to find out that the number equals 9.99. And do not forget the unit, kilogram, meters per second, because we are calculating momentum. And do not forget to mention the direction, because the bullet is going to the right. And here, do not forget the unit of velocity, meters per second.
خلصت توجيهي وبتدور على جامعة التعليم فيها قوي والهيئة التدريسية فيها مميزة والمختبرات فيها حديثة. التحق الآن بجامعة الشرق الأوسط. للاستفسار 079 71 22 3 صفار.